ISSCAS chemistry learners and everybody else interested in chemistry. We appreciate your company. From NAMCOL, the Namibian College of Open Learning, we have a series of 5 radio lessons on different interesting topics in your advanced subsidiary or AS chemistry syllabus. In Lesson 1, we discuss the framework structures of crystalline solids. Today, in Lesson 2, we look at the characteristic trends of Group 2 elements. If you are a NAMCOL student, you will find this topic in your textbook, AS Level Chemistry Learner book, in topic 3.2.1. That's on page 158 to page 162. If you are having challenges with Group 2 elements, this is the place where you can shake off that fear and get to know once and for all how the periodic table works. It's a very clever scientific tool, you know. We have 3 learning objectives for this lesson. They are to help you describe the reactions of Group 2 elements with oxygen and with water. Secondly, you will learn to describe the behavior of the oxides, hydroxides with water, and now you can listen in our chemistry class with me, Miss Bolton, and my learner Ushona. We will demonstrate the reactions of some of the Group 2 elements with oxygen and water.
Good day, Miss Bolton.
Hello, Ushona.
I heard you announcing that we're doing experiments today. That will be interesting.
Thanks for coming in to help me present this class. And yes, we have to investigate the reactions of the Group 2 elements with oxygen and water. I ask that you please pay good attention today, Ushana, and write down all your observations clearly.
Yes, ma'am.
First, let me tell you something about the Group 2 alkaline earth metals. They include, in increasing order of atomic mass, beryllium, magnesium, calcium, barium, strontium, and radium. These are soft silver metals that are less metallic in character than the Group 1 alkali metals. Although many characteristics are common throughout the group, the heavier metals such as calcium with a symbol of Ca, strontium Sr, barium Ba, and radium Ra are almost as reactive as the Group 1 alkali metals. It means that they easily and strongly react with other elements. All the elements in Group 2 have 2 electrons in their valence shells, giving them an oxidation state of +2. When reacting with oxygen, they form oxides, and in solution with water, they form hydroxides.
Oh, now I also understand what oxide and hydroxide mean.
As I said, these Group 2 metals are also known as alkaline earth metals. We will only investigate the 4 earth metals: magnesium, calcium, strontium, and barium. You may want to know a little about each of them.
Yes, ma'am.
Magnesium is the 8th most common element in the Earth's crust. Magnesium is light, silvery white in color, and tough. It forms a thin layer around itself to help prevent itself from rusting when exposed to air. Fine particles of magnesium can also catch on fire when exposed to air.
Interesting.
Calcium is the 20th element on the periodic table. Calcium is the 5th most abundant element by mass, both in the Earth's crust and in seawater. All living organisms have and need calcium for survival.
Learners, drink your milk and eat your fish.
Tell them, Ushona. Now, unlike calcium, Strontium does not occur as a free element in nature due to its extreme reactivity with oxygen and water. It easily becomes unstable and turns into another molecule.
I have questions about that element, miss.
Barium is a soft, silvery white metal and only melts at 725 degrees Celsius. Because of its reaction to air, barium cannot be found in nature in its pure form, but can be extracted from the mineral barite. You may find it interesting that barium compounds are added to fireworks to give a green color. In a purer form, it is used as X-ray radio contrast agents for imaging the human digestive tract. But water-soluble barium compounds are poisonous and have been used as rodenticides.
Rat poison, the same element can be used to light up the digestive tract and to poison rats?
Yes, it boggles the mind, doesn't it? Which reminds me, before we start, please note that whenever you are doing experiments, always wear protective clothing. You can get a lab coat and goggles in the cupboard there at the back, Ushona.
Is it really dangerous, these experiments?
We should never touch chemicals with bare hands. As you have heard, some of them are indeed dangerous, corrosive or poisonous. So you should learn from the start to work with protective clothing and gear.
Ah, I see. Yes, ma'am.
We will start with the reaction of the group 2 metals with oxygen.
Let me see. Group 2 on the periodic table. Beryllium?
No, we're focusing only on those 4, remember? Magnesium, calcium, strontium, and barium.
Sure, miss. One of those elements sounds a little crude if you know Afrikaans.
That's true. I was wondering whether you were going to say something. In fact, its name does not have any rude connotation at all. Strontium is named after the Scottish village of Strontian. Strontium is not very common in nature and only occurs naturally in compounds with other elements. It is softer than calcium and reacts with water more vigorously. It has a silver appearance but then turns yellow with the formation of oxide.
Good to know. Okay, miss. What should we do first?
First, we light the Bunsen burner. Now, watch while I burn these elements in this order. First the magnesium, then calcium, followed by the strontium and lastly barium. I want you to observe and tell me what happens when they heat up in the flame.
Shoo! That's the magnesium, right? It burns with a very bright white flame.
That's right. Magnesium burns with a bright white flame and then turns into a white solid after burning. Group 2 elements react with oxygen to produce oxides. We'll keep this magnesium oxide because we'll use it again later. Now watch while I burn the calcium. Okay, I put it down here. And now the strontium. Can you see what happens?
Ah, yes. Both the calcium and strontium burns with red flames, not white like the magnesium.
Okay, watch now while I put this piece of barium over the flame.
Oh, a green flame. How cool is that?
That's right. Barium burns with a green flame, magnesium with white, calcium and strontium with red, and barium with a green flame. That's enough of these flames. Next, you should know that group 2 elements react with oxygen to produce oxides. We now have magnesium oxide, calcium oxide, and so on. The metals turn into a white solid after burning. Now we will see how these elements respond to water. Are you ready?
I'm a little scared, but ready.
No need to be scared. Place each of these into test tubes with water. Then we see what happens.
The magnesium seems to be reacting very slowly. On the other hand, calcium reacts faster and forms more bubbles. It forms a white solution, the calcium hydroxide. Now the barium. Oh, wow! The barium reacts the fastest out of all the 4 elements.
Yes. So what is your observation with regards to the elements and their reaction with water?
I see that it's like the elements responded faster every time, starting with the magnesium, then the calcium, then the barium.
Exactly. In other words, reactivity with water increases the further down you move in group 2 of the periodic table. Now, we have a few elements with water, meaning they are all now called solutions. They have reacted with oxygen and formed oxides. Then they also reacted with water to form hydroxides. The next observation has to do with the pH value of the elements, how acidic or alkaline each solution is. The presence of bubbles indicates that there is a gas being released.
Is it hydrogen gas?
Yes, it is. Well done. Now, Ushona, take this pipette and put a drop of each of the solutions onto this universal indicator. Let's see what's happening.
Oh, so the universal indicator is green in color, but with the magnesium hydroxide, it has now turned blue.
Ah, the magnesium hydroxide makes the green indicator blue. What happens with calcium hydroxide?
Let me see. The calcium hydroxide makes it even a deeper blue. It's purple.
Cool, hey? Now, do the same with the strontium and barium solutions.
Okay, I see. The indicator gets a much darker purple every time with strontium and barium solutions.
So your observation about this is?
That solutions get bluer from magnesium through calcium to strontium and barium, the darkest blue.
Yes, but it's not about the color, Ushona. What color is acidic and what color is alkaline?
Oh, that's what you mean. Of course, blue means it's alkaline. So you mean all the solutions formed when group 2 elements react with water are alkaline in nature?
Yes, exactly. We say that group 2 metals plus water gives a metal hydroxide and hydrogen gas.
The hydroxide is the alkaline solution, I assume. Oh, yes. I have learned a lot today. I have seen that among the group 2 elements, magnesium burns with an intense white light. Calcium and strontium burns with red flames, and barium gives a green flame. The oxides produced are white solids with high melting points. Group 2 elements also react with water with increasing reactivity down the group to form hydroxides. Group 2 oxides react with water more readily down the group to form aqueous hydroxides with increasing alkalinity.
Thank you and well done, Ushona. Learners, you have heard about basic trends in properties of the group 2 elements of magnesium, calcium, strontium, and barium. You have heard what compounds they form in reaction with oxygen and the behavior of oxides and hydroxides with water. This wraps up our lesson for today. NAMCOL has many more radio lessons that can help you brush up on exciting school topics in your grade. Thanks for tuning in. Please keep listening and we'll speak again soon.
This lesson is produced by NAMCOL with funding from the Ministry of Education, Arts and Culture.